So, Bismillahirrahmanirrahim. Thank you everyone for joining. I'm Naveed Iftihar. I'm co-founder of Atom Camp Arabia. I'll introduce Atom Camp Arabia later to you. On behalf of Atom Camp Arabia and طويق Academy, I warmly welcome all of you. And I know this is a weekend, and I think that really shows your commitment for artificial intelligence and the intelligent future as well. So, thank you everyone for joining. Today we are going to talk about AI for manufacturing, and that we will be focusing on Industry 4.0 manufacturing. But to start with, I'd just like to introduce you to my organization, Atom Camp, and then I'll also introduce today's speaker. So I'm co-founder of Atom Camp Arabia. So what is Atom Camp Arabia? Is an AI and emerging tech training platform. So we specialize in artificial intelligence, data science, and emerging technologies. So we conduct boot camps. We conduct B2C boot camps. We also conduct B2B boot camps for companies, for government sector. So where we train the workforce in artificial intelligence. So our unique edge is teaching the data science mindset, problem solving, and critical thinking. So we do not just teach tools, we actually teach how to apply AI to solve everyday problems. And whether you want to solve with data and AI, so this is where we stand out. How do we do it? We do online B2C trainings. We've been doing it globally, but we are starting it in Pakistan. Started from Pakistan, then we went in other countries, in the US, in UK, in other Central Asian countries, and now we are expanding in the Kingdom of Saudi Arabia. So we will be announcing online boot camps. These boot camps will be certified by Microsoft. So I think within a week or so, we will be launching these online boot camps. We have a stream that is corporate upskilling. So we upskill the workforce in AI in any industry that people are working in. And similarly, we are working closely with government authorities to train the youth and also to train them in a way that they can so also to train them in applying AI to solve public problems. So that is something that we have planned, and we offer a comprehensive ecosystem. What we do actually, we try to build a community. That community is not there just to attend a course. That community is there for lifelong professional connections and partnerships where they can support each other and they can learn from each other. So this is the key part in our process. So what actually, holistic learning journey that we shape, and also we bring domain specific experience, whether this is in Kingdom, in the US, in many parts of the world. So far, Atom Camp Arabia launched its operations in the last leap that happened this year earlier. And we announced our plans to train 20,000 Saudi workforce in artificial intelligence by 2030. So this is our plan that we are working towards. And this seminar is also part of that broader plan where we can enhance understanding and also help the youth and professionals learn artificial intelligence. We've done multiple workshops in Riyadh, in Dammam, in many parts of. We've recently concluded a boot camp with Wadi Taiba. It was in partnership with Wadi Taiba and Ilm. So Abdullah is our colleague sitting right here. So he's graduate of our boot camp, but now he has joined Atom Camp Arabia as well. And you can see he was the top performer. That's why he's part of Atom Camp. So this is our journey that we've been doing. We've conducted trainings and workshops like AI for banking. that we conducted at MCIT. And similarly, we conducted trainings in AI for education and AI for startups. This is actually AI for city management, the last talk that we conducted here. And today's talk is AI for manufacturing. And on 7th of July, we will be conducting a talk on AI for healthcare. So far, we've started recently. We've done workshops similarly with KFUPM, with Cream here in Saudi Arabia, with Tamimi Group. And also, these are some of the programs, our training programs that we offer in generative AI, mobile app development, low code, no code workshops, and data engineering. So there are upcoming workshops that we have planned. I think 2 of them are planned in Riyadh, and one of the workshops is going to happen in Dammam. So you can scan this QR code, and also you can visit atomcamparabia.com, and you can see those workshops. You can enroll in those workshops. So there will be a certificate of those workshops as well, and networking with the professionals who are already learning AI, and you can also interact with them. So it will be a learning, certification, as well as a networking event. Yeah, sorry. Is it okay? Okay. So these are our socials. You can follow for updates and upcoming workshops, events, seminars, and many other activities that we've planned. So that's all on Atom Camp Arabia introduction. For today's seminar, we have Dr. Zubair Khalid. He will introduce himself. He's an academic and also with an extensive experience of helping industries globally in adopting artificial intelligence. He has also served for 2 years at KAUST. He was professor at KAUST, and he continues to do research with KAUST. So along with that, so AI in manufacturing, because this is a very interesting time in the kingdom with Saudi Vision 2030 and the recent announcements, the partnerships with Humane and NVIDIA. The plan is to move towards robotics and AI factories in the kingdom. So that vision, how to achieve that vision actually, how to implement AI in manufacturing, this is going to be the focus of today's seminar. So we train people to develop AI solutions for manufacturing, and we also have a solutions arm that we are already providing AI services and solutions to manufacturing companies. Dr. Zubair will be sharing the broader ideas of AI manufacturing, his work, and we will also share the work that we are doing in the kingdom. So with that, I will request Dr. Zubair Khalid to join us and to give this talk. Thank you, Dr. Zubair. Thank you.
Bismillahirrahmanirrahim. Assalamu alaikum, everyone. Yeah, good evening. Pleased to be here, and thank you, Atom Camp, for inviting me here. So it's my second time in Riyadh, and I'm loving it. I'm loving the traffic. I know it's too much. Yeah. Today I will focus on AI for manufacturing, and we will talk about some use cases in how we can apply AI for different applications in industries. I know that some of you are coming from industries. It would be great if you keep this session interacting. Please feel free to interrupt for your feedback, for your constructive suggestions, for your comments, and if you have any questions, feel free to interrupt. Right? Okay. So I will start with a brief introduction about myself. I worked as a professor at KAUST from 2023-2024. Where I worked on a couple of AI-driven problems on climate modeling. Primarily, I am based in Lahore University of Management Sciences, which is, in my view, a counterpart of KAUST in Pakistan. Before that, I was postdoc at Australian National University in Australia, from where I did my PhD in artificial intelligence and machine learning. Sorry? Yeah, I'm Aussie. Yeah, okay. Oz. Okay. 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 Thank you. Okay. Yeah. So I would like to highlight. I'm very humble to tell you that when I worked at Kaust, our work has been awarded this Gordon Bell Award, which is considered as a Nobel of supercomputing. And this is the first time that that award has been given to Kingdom, or in fact, in this region. The Kaust, I was part of the Kaust team, and when we got this award, right? Okay. The agenda for today, we will start with a brief introduction to AI and Industry 4.0. I know you are aware of AI, but I will, for the sake of completeness, I will start with some fundamentals as well, right? And then we'll focus on what do we mean by AI in manufacturing and technologies. Then we will see some use cases of AI in manufacturing industry, ranging from predictive maintenance, quality control, safety, and supply chain. And then finally, we'll conclude with how can we develop AI strategy for your industries, or for manufacturing industries. Okay. Before we start with the first topic, so what tasks in the manufacturing plant industry do you think AI can automate today? Because we have people from industries. Anyone would like to add anything? If you think, what could be tasks?
Especially materials that are coming out of the pipeline when you're trying to achieve the quality.
Great. So thank you very much. And we will have at least 5 to 6 use cases about this. Yeah. Quality inspection is something in which people had been using manual checking for parts, but this can be automated using AI, and this can be done in real time. And there are lots of benefits to do that. Anything else?
An oil refinery.
An oil refinery. What application?
I think they check the pipes.
For leakage.
Yeah.
Right. Great. Yeah. So I had a colleague at Kaust who used to develop that smart flow meters, and using RF technology, they could sense the signal and they can find out the leakage at a distance as well. The company name is Sahar Flow. Yeah. It's one of the startups coming from Saudi Arabia, and they have won many awards internationally as well. From any applications?
For example, we have for counter machine in the schedule bar. Before the waters are counting.
Okay.
Yeah, manually. Now we have machine.
Okay.
With the sensor count everything.
Okay. Great.
To avoid it, stop safety and make it fast.
Okay. Yeah. So this is an automation in which you could deploy a sensor and you could count it, right? So this is typically a digital transformation, right? Because the sensors have become cheap, and now you have more compute power. You can do this in real time, right? But in fact, with AI, you can take it to the next level. You can do inspection as well, as you said, right? In addition to counting, you can do inspection as well, whether the bottle is complying with the quality checks or not, right? Okay, great. Thank you, everyone. So let's start with a brief introduction to AI Industry 4.0. I will start with Industry 4.0 overview. I think, are you aware of this term? These days we're talking about Industry 5.0 as well, almost 5.0, right? But so far, before Industry 4.0, we have seen 3 industrial revolutions, right? The first one was driven by mechanics, the steam power engines, right? When they came in back in late 17th century, so it happened in Britain, right? And they started this mass production using steam power and water power, right? The second revolution was, industrial revolution was 1870. And that was triggered by electricity and combustion engines. Being electrical engineer, I call the Maxwell's equations. Right? If some double is here, the Maxwell's equations triggered that. Right? Typically, we say in physics that God said Maxwell's equations, and then there was electricity. Right? So the second revolution was triggered by electricity and combustion engines, and we start getting cars. The first Ford cars coming out in that revolution. Third revolution was triggered by computer and digital technologies. In fact, if I talk about, it started with transistors, because transistors served as a backbone of computers, right? So that triggered the third industrial revolution. But now we are saying almost fifth one, right? I will start with four first, and then we'll talk about fifth one, right? And it is changing everything, the way we work, the way we interact, the way we live. And that is because of the key enablers are AI, industrial Internet of Things. We have a lot of data these days. And so this data is coming from what happened here, right? But now since we have more compute power, so we can handle the big data, we can store the big data, and we can process it, we can extract insight from the data, right? Okay. And then we have predictive modeling, machine vision, cyber physical systems, smart sensors. We'll talk about these very shortly, right? But what's next? We're going to see Industry 4.0 very shortly. There's no formal definition of 5.0, but what I envision is that this will be an era in which robots would be very common in industries or in daily life as well. In my view, what AI was in the last couple of years, it will be robotics in the next couple of years. So there will be demand for electrical engineers again. Yeah, so computer science is demand these days. I have CS faculty here, but I feel that EE would be back again. Okay, because EE would be driving this Industry 5.0 revolution. Okay. So coming back to Industry 4.0, the major component is what we know as cyber physical systems. Right? Cyber physical system is a system in which you have sensors deployed in an industry or in a network or in an oil industry, and you're getting data from those, right? And those systems are interacting with each other, right? They are cyber physical systems. But with AI, this paradigm has changed over the last 10, 20 years. So now cyber physical system has attained a new level. We call it next gen cyber physical systems, in which I know in the industries here, so we have SCADA or ERP systems or MES systems deployed that are generating large amount of data. So previously, so this data had been here for a long time, but now we have access to this data together, and we know that the data coming out of planning, out of the machines, so there should be a relationship between the data, right? Because maintenance data, operation data, supply chain, planning, so all this data is interconnected, and now you have access to this. And since we have access to this, we call it big data, so we can develop methodologies and technologies here so that you can extract insight from the data. You can do predictive maintenance, quality inspection, a better planning, so you can improve safety on the plant. So now we are having this next generation cyber physical systems, right? So for any industry, it should gauge that what is the readiness level for Industry 4.0. It means whether the industry is ready to adopt the standards or to fully exploit the benefits given by Industry 4.0, right? And when we say readiness level, it should be across different functional areas of Industry 4.0. So it should be production ready, supply chain or logistics should be promoting the adoption of Industry 4.0, sales and marketing, service development. So across all these functional areas, in any industry, you have, in some form, you have these functional areas. And across these functional areas, so we should have readiness across process, across organization, and the adoption of technology, right? So this is a standard Industry 4.0 readiness assessment framework, right? For any industry, if it wants to adopt 4.0, this should be a starting point. They should first evaluate what is the current readiness level, right? Okay. Any questions, comments? Please. Okay, sure. Okay. let's say an industry wants to devise a strategy for Industry 4.0, right? So they should know from where they start, right? And for that, they should first evaluate if they are ready or not, right? So they should be ready across different functional areas, right? So production, supply chain logistics, sales and marketing, and those two. And then there are different verticals of an organization. Their processes should be ready. Their organization structure should be ready. Their workforce should be trained. And they should have appropriate technology. They should evaluate their readiness around this, using this framework. And when they use this framework, they get a score. Score, for example, for cloud usage, out of 5. If they don't have cloud usage, they'll get a score of, say, 1 out of 5, right? It means they need to, so this framework will help them in devising a strategy, in selecting an area, in shortlisting an area in which they should focus. Right? Okay.
So who can evaluate this?
Yeah, so there is, so this is from the Boston Consulting Group, BCG, and they have a set of questionnaires. They have a set of interviews. So you can get a qualitative data and you can get a quantitative data. Yeah, you can. In fact, this is publicly available. Anyone can evaluate their industry on their own. Okay, thank you. Okay, and typically we divide industries into 3 categories when it comes to Industry 4.0 adoption. We have starters, we have experimenters, and then we have scalers, right? And this is from the report by McKinsey. But when I work with different industries, I typically see that most of the time the industries are in the orange phase. They are experimenters. They are struggling with ROI and deployment. They come up with one use case and then it is not technically it is not economically feasible, and therefore they remain in that stage. And the solution, the transition from this orange to green can be enabled with this. In fact, you can have the same philosophy for any transition, right? So they should slow down to regroup around a focused strategy that prioritizes high impact use cases and a clear deployment roadmap to scale digital transformation successfully. So I will talk about later in the presentation one matrix that can really highlight what could be high impact use cases, and so that how can you develop a clear deployment roadmap, right? Okay. So that was a brief overview of Industry 4.0 and adoption. Let's start with AI. What is AI? Now you know this, right? Okay. What is intelligence? Sorry? Yeah. Yeah. But what's intelligence here? Thank you. Yeah. AI means you want to mimic the human intelligence. But what is human intelligence? How to? How to learn. Yeah. This is my definition. It's an ability to learn, understand, and apply knowledge, to adapt to new situations, to knowledge to reason, and then solve problems, right? So as humans, so this is the capability Allah subhanahu wa ta'ala has given to us, right? Naturally, right? And human intelligence involves problem solving and reasoning. So we learn from experience, we're adaptable, and to me, it's most important, we have emotional intelligence, right? So this is something hard to achieve using AI, by the way. Okay. It should be, right? Okay. But what is AI? As you said, yeah, we are trying to mimic the cognitive functions. We're trying to mimic what humans can do, what intelligence can, right? So AI is a broad area in which we have subdomains. So machine learning is the core of AI, and then we have deep learning. So in machine learning corresponds to if you have an ability to perform tasks without express instructions or relying on patterns. And then we have deep learning, which is a subfield of machine learning, right? But AI is a bigger umbrella that encapsulates these two. Questions? All good? Start boring?
I believe I have a point.
Please.
Point on the slide before this one.
Yeah.
So what's the difference between the human intelligence and AI?
Yeah.
From my point of view, I see there is one huge point,
Yeah.
which is the emotional intelligence, not the emotion.
Most intelligence?
Emotional intelligence.
Yeah, emotional. Yeah. Agree.
So not the emotions is what you feel, like what
Yeah,
you feel
yeah.
inside.
Yeah.
Emotional is what you touch.
Yeah.
I believe this is a huge point missing from the human intelligence to the AI.
Yeah, this is what I said earlier. Yeah, agree. Thank you. Absolutely. Yeah. So you were saying more. Go ahead.
No, that's because I think there is a difference between emotional and emotional. Okay, so as a human
Okay, emotional.
yeah.
Yeah,
So
okay.
as a human being, I have motion of sense, which is
Yeah, okay.
seeing, tasting, smelling. So I believe the biggest difference between the human intelligence
Yeah.
and the artificial intelligence is the emotional.
Typically, we have these psychomotor skills in which you can have sense, but cameras, right? You can say you have vision, but you have cameras these days. So you will have robotics coming up, which will have with sensors as well, which can really mimic how we touch or how we feel. But yeah, we are not there yet. Yeah, we are moving towards emotional, but more challenging would be emotional, in my view. Yeah. Okay, thank you. Yeah, I agree. I totally agree with you. Any other comments? Or anyone wants to add anything? All good? Okay, thank you. Okay, history of AI. AI has been around for many decades, right? So I think, in fact, this term was first coined back in 1956 in a conference, right? But what has really changed in the last 10 years? That really enabled this AI? Data. Yeah, data had been around, right? Yeah, but yeah, the storage of data, access to data. What else? The compute power we have these days, that has really enabled, because now you can extract, you can handle large amount of data, and you can extract insights from the data, right? And what enabled that compute power? GPUs, right? GPUs were not designed and initially developed for AI. They were initially developed for gaming industry. I know this, okay. Yeah. So something developed for gaming industry, right? And people saw that, okay, now these smart computing units, GPUs, can really accelerate the computing. And that's how people adopted that and started using in developing models that can really scale to the large amount of data. Okay, yeah, so we know all these terms, machine learning, multi-agent systems, computer vision, planning, game theory, for the last 30, 40 years. But deep learning breakthrough was the one that really enabled this AI paradigm. Then we have types of AI. I think this is very standard. Narrow AI, general AI. Narrow AI means if you have a machine or a system capable to do some specific task. General AI, if a machine or system can do multiple tasks and those tasks and interact with each other as well, right? Like a human do, right? And then we talk about super intelligent AI, which we call super intelligence. So if machines or robots can get a capability in which intelligence really surpasses the human intelligence, this will be known as super intelligence, right? Are we there yet? No, right? But in some applications, very specific applications, we can say that we have achieved at least human level, or in fact, we have surpassed human intelligence. I think so. We have one guy here who works in computer vision. But in computer vision is an area in which we say that we have really surpassed human intelligence, because if you have real-time systems, machine running at a very high speed, and if you deploy a person there, you cannot see what's going on, the defects. But with those cameras and capability to do computation real time, you can do that, right? Those small-scale defects that could not be detected by humans, but machines can do that. Okay, one more question. Could you identify 2 fascinating AI applications that are making waves? When you used to ask this question 5 years back, the answers were different, but now the answers are different.
Why?
Because things have changed, right? The context has changed. Things have evolved. What are 2 key applications? 2 fascinating that really fascinate you.
I think one of the applications found in Russia,
Uh-huh.
we have a mixer,
Okay.
a lot of mixer. And
Mhm.
this mixer makes a couple of chemicals in the compound. They use an algorithm that can detect the flame. If the mix wasn't correct, the flame will emit some sort of colors. By using AI, they can identify a mixer that is incorrect, and the process will be shut down.
Great. So this is really fascinating, right? So something happening chemically, right? So that has been translated to the color of the flame. And from just looking at the color of the flame, you can trace back what was wrong there, what was going on there, right? So this is known as mapping, right? Mapping a very complex process just by looking at the flame of the color. It's a very fascinating application. One application that we use every day that has really changed.
Google Maps.
Google Maps, yeah. Google Maps, yeah. So the algorithms behind Google Maps is, yeah, you can say that that's a good application of AI. Yeah. So these days, what I feel, autonomous cars, I think we're not very far from autonomous cars. So this is a very fascinating application of AI, because in those autonomous cars, you have sensors deployed, cameras, lidars, and you're making decisions in real time, getting all the massive data, and you make this in real time, right? And one more fascinating application is large language model, right? Like DeepSeek, GPT, right? Something like that, right? So these have really changed. They're making waves these days. Okay. I think in the interest of time, I will skip this. This is very standard. Okay, and coming back, so we know AI, we know Industry 4.0. Let's start applying AI in manufacturing, and what are technologies that really enable AI. Right? I hope it's not too boring, right? Are you awake? Okay, good. Okay, thank you. Yeah, so some uses of AI in manufacturing. We can predict using AI. It means, what do you mean by prediction? Prediction means you anticipate future, you anticipate the output based on existing data patterns, right? The flame application, it is indeed a prediction. You look at the flame and you get the output. It's a prediction, right? So you use a camera and see whether a person is in front of a camera or not. It's a prediction, right? Good. Demand forecasting is a prediction. Analyze, again, analyze is, I think what you said is a mix of analysis and prediction. You can control, this falls in typically robotics or process optimization, to dynamically and automatically manage processes. And this is large language model, where you can really generate content as well, right? So large language models, they do not copy the content. They just generate the content from noise. They simply start with some noise. A noise means something that does not contain any information, and they structure that noise in a way that what you get, a sentence in the end, is something meaningful that has structure embedded in it, right? So these are generating content. Okay, we will talk about these four in today's seminar. We'll go into details of these four. We'll talk about these four very shortly. How AI works in manufacturing, we'll start with, for sure, the most important thing, the data. So we have sensors in industries, in manufacturing plants. We have IoT devices that are capturing real-time operational data. And then we have continuous monitoring of equipment and environment. So this data goes into the machine learning models where you can do analysis, where you can do prediction, where you can do inference. And finally, from output of machine learning model, you can do real-time analytics, whether you want to stop that process or not, or whether you want to stop a car or not, and so on and so forth. Right? Okay. So the key technologies that are enabling the use of AI in Industry 4.0 are, and these four, there's a long list, but I think these four are the most important. We have natural language processing these days that can really understand the content coming from different languages, and you can really do a real-time conversation as well using NLP. We have machine learning that forms a backbone of everything. Computer vision, in which it means you use cameras to sense. And we have very high resolution vision capability these days. And finally, we have agentic AI, which is just a combination of machine learning and NLP. Right? It means you can develop agents that can really automate the process. Right? So you all know computer vision, right? But for the sake of completeness, very briefly, computer vision means you scan the environment, you look at industry floor or warehouse using cameras, and you use the output of the cameras.
If you like anyone's question, you can give that.
Okay, gifts. Okay, thank you.
Only good questions.
Okay.
Every question is good question.
Okay. We have incentive as well now. Okay. Okay. Yeah, so we can use computer vision means you can scan and you can make decisions from the stream coming from the camera. Right? But AI has really changed the paradigm of computer vision. So previously, we used to get camera stream, and we collect the data, we store the visual data, and then you make decisions perhaps later. But having more compute power, having computationally efficient algorithms has enabled that we can make decisions in real time. So you look at, you count the objects, or you look at the object and if the part is defective, you can generate an alarm in real time in industry and just trigger that object needs to be removed, right? In counting application you mentioned, right? If the count is not right, if some object is missing, you can make a decision in real time, right? So previously we did not have this capability, but now AI has really enabled this. A branch of computer vision is known as machine vision, right? It's different from computer vision in a sense that we use very specialized cameras for machine vision applications. We cannot use the standard CCTV cameras for machine vision. Machine vision simply means you can have automated visual inspection of manufactured things using industrial cameras, lenses, and lighting. One important thing that really differentiates machine vision from computer vision is the role of illumination. So the lighting plays a very important role, because in the industrial control setting, you have a control on lighting. You can control the environmental conditions. You can control what should be the light on a particular object. So that can really enhance the performance of the underlying algorithms. Machine vision is known as, or cameras are known as eyes of Industry 4.0, right? Because you need to sense first, and then you analyze and make a decision, right? Sorry. So machine vision or cameras, they're known as in the eyes of Industry 4.0. Okay. So let's look at some applications of AI-driven machine vision industry, right? So there are a bunch of applications. We'll talk about some more in more detail.
barcode reading, OCR, advanced color tools,
Yeah, we can do that.
deep learning tools. These industry-leading solutions solve simple to highly complex applications like pick-and-place robotic.
So we used to have quality inspection through sampling before, right? You select a sample from the tray and you take it to quality lab and make a decision. But now you can do this in real time for each object, right? So that this capability is driven by the compute power and AI these days. Right? So some applications include of machine vision. You can do real-time inspection for defects, for some illegal objects. We can gauge whether the object that is being produced is of right quality and size or not. Guidance, for example, you want to guide a robot to remove a defective object from the conveyor belt. We can use machine vision and identification as well. Whether the product you are dispatching from your industry going to a particular customer is of the same customer or not. So there's no mixing of products going on in the finishing line, right? So you can do all that using machine vision. So inspection, gauging, guidance, identification, right? So we have talked about AI in manufacturing technologies. Now let's zoom in and look at some applications in more detail, right? So I will start with AI-driven predictive maintenance. So we have people from industry. How do we do maintenance in industry these days? Maintaining machines or? Okay.
Thank you. Much appreciated.
Okay. How do you do that? Manuals.
By the recommendation of the manufacturer, for example, a part.
Good. Yeah. Yeah. So you do you follow the manual that is given by the right. But that's for the machine, right? But when you connect different machines, they interact with each other, they influence each other, right? So what is the most failing part in industry, typically in process industry? Motors, right? Typically, yeah. The industry itself, right? Yeah.
Well, in particular, generators.
Generators and motors. You know, motor is a generator, you know. Yeah, it's okay, okay, okay. Yeah.
In our case, we have maintenance, daily maintenance.
Okay.
Depending on the
Okay. So typically we do planned maintenance, right? Yeah. Or you go and inspect, right? So it, right?
In our case, it depends on the situation. Let's say we are in the oil field.
Mm-hmm.
Let's say we have a machine. The material go out.
Okay.
If the solving the problem will take a long time, this case we will stop. Or if there is a problem with water, carry on like this.
Okay. The scenario. Okay.
Problem. Also, we don't have any problem. Every day we have to stop.
Okay. So it means, but if you could sense that the problem is going to occur to this machine, say, maybe to be very optimal, maybe 5 days in advance or 1 hour in advance or say 10 minutes in advance, right? You can take remedial action, right? So that is going to impact on reduced downtime. You don't need to stop the machine. That improves efficiency and so on and so forth, right? And if you can do this in real time, that would be great, right? So that is a switch from planned maintenance to predictive maintenance. If you can really predict the need to maintain a machine or maintain a motor and so on and so forth. Yeah. 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 Great. Vibration is a very, thank you for highlighting this. Vibration is a very classical example given for in this case, because vibrations can really sense what's going on with the motor gear, right? And if the motor is about to malfunction, the pattern of vibration changes. And just by sensing the vibration pattern, you can predict that there is a possibility that this motor will malfunction in a couple of days, right? So in process industry, we can do predictive maintenance. So we can have sensors that detect sounds or vibrations and send their data to AI engine. So we have machine learning algorithms that can predict the maintenance needs. You send the signal, you update the maintenance schedule based on the recommendations coming from here, in addition to recommendations from the manufacturer, right? And finally, you can reduce downtime. Okay, this is a standard transition from preventive to predictive maintenance. Okay, this is one example in which we did work with Tetra Pak Jeddah. Tetra Pak is a company that manufactures the packages for the food, milk and juices, right? Tetra Pak, you know this, right? So the juices in a pack you get from the market, they're in Tetra Pak packaging, right? So what they produce is they produce these types of rolls, and then this roll goes to the almarai filling machine, and then they produce the boxes, right? Okay, so typically this machine is run at a very high speed. So this roll is being produced at, say, 650 meters per minute, right? And this is 1.5 meter wide, right? And so one roll comes out, another roll comes in, and this is the supplies, the cut is in real time, right? So let me explain. See, this is being produced. So this will be cut, and this will come forward, and the next roll will start producing, right? This is all happening in real time, right? What is going to happen if this supplies is not applied correctly? Yeah, right? It means they will have to stop the machine, right? Start the process again. And typically the process is like a almost 500 meter long process line. They will have to start the process again, and it will take around 5 to 6 hours to start the process again, to adjust some parameters, right? So this supply miss was a problem, right? So what we did is, we deployed a very high speed camera, right, to monitor what's going on to the blade that cuts the splice, right? This is the application, right? So this will be the high speed one. This is a slow motion version of this, right? See, this is a knife. This will move and the cut, and this is going on, and this starts producing, right? So with this camera, now we feed this video, this slow motion video, to a machine learning system, and machine learning system can detect what is the probability that next supplies would be a failure, right? So they can slow down the machine close to the supplies, right? They can do the maintenance of supplies, so they can do the maintenance of the knife, and so on and so forth, right? So this capability has reduced the global problem that was in all factories globally, the supplies miss problem, right? So we're moving from predictive maintenance to, planned maintenance to, in fact, there was no maintenance. So this is now predictive maintenance. And so this is an application from, again, paper industry, in which we deployed these machine vision cameras to find out what are the defects. Again, the paper is going in at 650 or 700 meters per minute. I will quickly skip this. You can find cracks on edges, because if the crack is beyond a certain size, it will tear apart the whole web, and then the machine will be down again, right? Okay. Can detect. Okay. So we have two cameras on both sides. Okay. Okay. So coming from maintenance, now we move towards quality, right? This is an example from the car industry, in which they are using machine vision, the cameras again, to detect the paint quality as well, to measure the paint quality. So they use machine vision cameras, which fuel the AI engine, Again, ML algorithms, they detect defects. And then if there is some roughness or the paint is not applied on the say bonnet of the car, so the operator here, so he or she gets a signal and then they can correct the defects, right? This is an application of quality control, right? Some applications of AI in supply chain. Any questions? Now notebook. Any questions? Comments? Awesome. Yeah. Can you relate any of these in your industry? Yeah, please go ahead.
So I started in the 1970s, so I think you're familiar with something called the coupling.
Yeah.
So it is the torque transformer between the pump, motor, and the gearbox.
Yeah.
So nowadays, even it's applicated the Riyadh also for the torque transformation. A company called Blender initiated an AI sensor to put inside the coupling for any torque loss. So it's a predictive maintenance.
Great.
Any torque loss in Riyadh Metro, let's say, a torque will drop down, it will shut down the line directly, and call the maintenance team to this
Great.
site exactly.
Is it operational?
Yes.
Okay, great. Great. So see, we see these things in action as well. Thank you. Thank you for. Anyone else wants to add? Questions, comments? Any volunteer? All good? Please.
Is it most important for your employee intelligence?
Can you see from here? Well, you can come there. Come on. Yeah, come on. I can put a chair for you. You can come here. Can you see? Okay.
Is it important for most employed AI in the industry here? Or not?
It is?
You must employ the AI.
Yeah.
Train here.
Yeah, they were saying that he's saying that they have deployed the solution in Riyadh Metro, in which there is a sensor on the coupling that connects the gearbox with the generator, with the engine. And on that coupling, there's a sensor, and that sensor is sensing whether there's a vibration or not, or some sensing, and that informs the operator that there is a need to do the maintenance. So they have deployed. Okay. Okay. Any questions? Okay. Let's move forward. Now we'll talk about some applications of AI in supply chain. Right. I will start with optimization of delivery of goods. So in industries and that manufacture items, and so they will have to ship eventually the goods to different places in a city, right? You can do route optimization, that what route should a vehicle take so that it needs to cover less distance, and that will have consequences on travel time, less emissions, right? Less traffic, right? So with better route optimization these days, so we can reduce the travel time from, for say, this is just one example in which we worked with one logistic company, and we provided the routes to them, the optimal routes for their deliveries. And we, on average, the distance covered by their delivery vehicle reduced from 44 kilometers to 35 kilometers. So each vehicle is traveling 7 kilometers per day less. And when you translate that to month or hundreds of delivery vehicles, so it's huge number of kilometers, and you translate that to CO2 emissions, it's a big number, right? Okay. So you can do better route optimization using AI. Another application which would be of interest in many industries is forecasting. Right? Typically talk about sales forecasting, demand forecasting, but these days we talk about spatial and temporal forecasting together, right? For example, we can have, this is the city of Melbourne data. This is a distribution of the requirement or demand of one product in the city, right? We have less demand here, we have more demand here, because this is a metro, this is a center of a city, we have less people here, more offices. In the residential area, there's more demand. And when you look at one point in space, you get demand something like this, right? The demand is less in this period, and again, the demand keeps on increasing. And the idea is, if you have historical data, if you know historical demand, can you predict the demand? Can you do the future demand, right? This is a standard forecasting problem, right? So if you only forecast this is forecasting in time, right? But if we really want to do space-time forecasting, it means for every point in space, we should learn how the demand is changing in time, right? Okay. So for this problem, for this type of problem, what can be done, or what we would typically do is, so you can divide the region into different regions, right? For example, this is a city, and you divide city into different spatial regions, right? And you train a different model for each region. Can't we use just one model for the entire city and for every region?
Yes. It's similar.
Yeah. Okay. Oh, great. Thank you. Yeah. But typically, you don't expect similarity, right? We saw the demand was different, right? Because in cities or in any delivery area, the demographics are different, right? You have population, socioeconomics, they're different, right? You have some more elite people living there, there's a different demand pattern, and in some other region, the different pattern, and so on and so forth, right? So it would be good to have a different model for different types of regions. Ideally, so what we did is, so we divided it into 2 kilometer by 2 kilometer small grids. Even there's a possibility that for some problem, this needs to be further reduced. So what are we assuming here? That in this 2 kilometer by 2 kilometer grid, the demand pattern does not change, right?
Actually, we have a similar problem with this.
Okay.
If you look at the pattern of people, North Real, it's actually diverse and far diverted from South Real.
Okay. Yeah. Okay.
For example, people commute from South Real 6 p.m. around 5 p.m.
Yeah.
And then when you have like map of the distribution from the warehouse, you have to move the car either before 5
Yeah.
or after 5, 6.
Yeah.
In North Real,
Different.
if you have a warehouse, you have to move the vehicles between 10 to 9 to match up the pattern. So defining the Real actually as a region and then define the model on the region can be effective, and this is happening from real data and real cases.
Okay, great, yeah. So you cannot fit one model because there are variations in space, and demographics are different. The factors influencing your inference, your predictions, they're different, right? Yeah, so therefore, now you have a capability that you can zoom into different regions, and you can do a better predictions. Please. Okay, are you done?
There is some time what's kind of
Sorry. Pardon?
to drive from the some road to drive here.
Okay.
We have navigation. The big trucks can be different in the road and the other time.
They're not allowed, right?
Yes.
Yeah, and they're typically allowed after some time, right? In the time window. Yeah, obviously when they're allowed, if they're allowed in that peak period, it's chaos, right? Okay. Right.
We'll have just 2-minute break. You can take a feedback session, and we'll continue.
Maybe 10 minutes break. If
5
you-
minutes.
We'll start.
And meanwhile, you can scan and you can.
You
give
should
your
come
feedback.
back. You want to pray? Maybe 10 minutes break then?
10 minutes?
10 minutes break.
Okay.
Okay.